So then here we have the compressor still running good. But what we have now, I did, so this control system really has always given us nothing but trouble. So I've kind of changed it a little bit. I'm not using this control anymore, I'm just using the major components like the relays, contactors and stuff like that. But then this cable here is new, and that goes to another controller I made. And that controller is up here. So basically the problem we had, like the temperature would not be controlled right, and chilled water would get quite warm, and then the boat doesn't cool very well. Like your air handlers will need a much higher velocity, so it makes a lot of noise, and also the cooling capacity is lower. So I put sensors here, there's sensors here, sensors there, sensors here, the various sensors I put on to the different fluids, like the raw water, chilled water. And I first wanted to kind of make this controller myself, I mean the actual electronics, but then I found out that like in milk factories have a very similar problem. Like in the milk factory, the fresh milk that comes in needs to be kept very near to freezing temperature, but it cannot freeze because then the milk gets damaged. So these here are milk tank controllers. I got 3 milk tank controllers. These are really nice programmable controllers. They're like industrial controls. They have a USB ports on them inside, and then what they do, you can set them, I mean they're quite ideal to what I was doing. So I just got these milk tank controllers, I wired them up together in a logic, and then there are 2 of them control, let's say, the compressors, and this one then controls these 2 and also measures the raw water temperature. So for example, if you would get a blockage in your raw water pump, like a plastic bag or algae or whatever, or octopus, whatever it is, and the temperature gets too hot, well then this one will then shut these 2 down to make sure that it doesn't get too hot. At the same time, the system that was before, like the electronics that they were before, what they would do, they would run both compressors like in tandem. They would start up and shut down together, which is not very good because there's actually quite a lot of latency in these pipes. The chilled water goes, down here. You can see it goes into the boat, and then it goes all around the boat and comes back, goes through all the air handlers. So there's a lot of latency there. So let's say you are cooling down. By the time you get a signal, by the time the sensors pick up the signal, there's a lot of inertia there, like thermal inertia. So then to get the water temperature as low as possible without freezing, the best is to drive the compressors separately. And then also that has the effect that, let's say both compressors kick in at the same time, you're gonna have a spike in demand, because when they start up they need much more power than when they're running, maybe double. So when both kick in at once, you could then overload the generator, which has happened to us sometimes. Let's say you have the water maker running or some big battery chargers, whatever, and then both compressors kick in and then the generator goes down. So this is programmed in a way that they're designed to never kick in both at the same time. That you will always, they will never both start up at the same time, so that gives you that benefit of not having the power spike, and also finer control over the water temperature. Right now that's keeping the water temperature around 2 degrees, which is I think pretty good. And it's quite stable there. So what will happen if the cooling demand really drops, it will shut down one compressor, it will then run on one compressor, but it will not cycle both in and out, because, as I say, it has the 2 effects. First, you cannot control the temperature fine, which we want. We want the temperature as low as possible without freezing, and then also the current surge. So now with the water running around 2 degrees, we can have the fan speed a lot lower and still get a lot of cooling effect. Or just what we're doing now, I'm having the saloon up the lowers full, so it's really cold inside now. Like it's a hot day, but it's very, very cold inside.